Okay, so welcome everybody. First of all, I'd like to apologize for having to reschedule the lecture. I had to go to London yesterday, so I couldn't really come and get the lecture. Your card readers will not work, as I've been told by a lot of you, so theoretically it shouldn't work for anybody. Don't worry about it. I'll go in manually and set everybody as having attended later on, so we don't need to worry about this. All right. Today we're going to make a start on the lab sheets that I want us to get through on this teaching block. So we'll start with the installation of the operating system. I will go through the first lab sheet and I will show you a couple of things on VMware itself as well, because it's very important that you get these first few steps correct, because if you don't, then something might go wrong later on a teaching block and you have to rebuild the virtual machine itself. So that's why I'll do a little bit of a short demonstration on my laptop of what we will be doing. So the lab sheet that was the first one is the CentOS installation lab sheet. So the idea is that we learn about the operating system itself. So we will be using CentOS, which is Red Hat Enterprise Linux. Okay, and the way that we will use this is we will have a virtual machine built on our host computers where you can go and play around and not worry about breaking something on the computer itself. It runs in A2.NET. You will have a username and a password for an account in A2.NET, VM1 or VM2, depending on whether you're on a morning or afternoon group. And once you are in the labs and you're logged in, you will create this one virtual machine in which you will be working for the rest of the teaching block. So that's why it's important that we build this correctly from the beginning. So in order to do this, you need to follow the lab sheet pretty much step by step, follow the instructions in the lab sheet step by step. I will sort of do this on my laptop as well, because I want to show you a couple of details. So the idea is that we're building a virtual machine. So you will create a new virtual machine. And the first step that we need to be careful about is because VMware asks you what operating system you're installing and how you're actually installing it. We will be installing it from an ISO image that will be available on your computers to use. However, if we do this at this point, VMware will start an unattended installation, and we don't want this. We want to be able to customize the installation as much as possible with regards to partitioning and software installation, software selection, and everything else on the operating system. So in order to do that, we will say that we will install an operating system later. So essentially we'll build a blank virtual machine and then add the operating system later on. So if we click on here, install an OS later, go next, it will ask you what sort of operating system we're going for. We're going for Linux, and it's going to be CentOS 7 64-bit. And then from there on, this is the first important bit, the name of the virtual machine. So the name of the virtual machine will be Prometheus, and it's important that you set it on this step here, because from there on, all of the files that VMware creates will also be called Prometheus something on the host operating system. So you know that it's a virtual machine that you've built according to the specification of the lab itself, and that you don't need to worry about getting these files confused or something like that. Especially later on, because you can make a backup of this virtual machine. If it's named correctly, you will know what it is. Ideally, if you want to, you can even add your student number at the end of this, as long as there are no spaces in the name. Okay, so you can have it Prometheus UP123456 or whatever you like. All right, it's optional, it's up to you. It really doesn't matter that much. Next, we need to give it some hard drive space. By default, it's going to have 20 gigabytes of space, but because this is the virtual machine that will do everything on, we need to have quite a bit more, so we'll go for 200 gigabytes of space. In the lab sheet, there's no mention of whether to store or split the images, and so if it's not mentioned in the lab sheet, it means just accept the default answer. Okay, so this is a general rule for all of my lab sheets for the entire 3 years that you'll be here. So go next on this one, and then it gives you a review of the virtual machine that you created. So at that point, you can go to customize hardware. We do want to make it quite a bit more powerful than it is. So we're going to go for 16 gigabytes of RAM. The easiest way to do this is to actually click on the 16 GB on the slider. We do want to have 4 CPUs. And I'm doing this on Windows. Linux won't actually let you, but at some point you need to check this first option. This means that the virtual machine that you're building can run virtual machines inside it, and it will need to. Okay, so this will enable the virtualization extensions for the virtual machine that you're building. If it doesn't let you do it now, I'm pretty sure it doesn't let you do it now at this point when you're in Linux. Once you build the virtual machine, power it off, go into the settings of it on VMware and just check this box, because then afterwards you won't be able to run any virtual machines inside it. With this selected as well, network adapter will need to change it to bridge. And finally, this is where we change what we're doing, and we'll go to browse and we'll go to find the ISO image. You will have a CentOS 7 ISO image, and that's it. So if you close this and then finish, then you'll be able to start building the virtual machine. So it's there, you click play and it will run, and you'll have to do the installation steps. So this is how you actually build the hardware side of things of the virtual machine that you want to be using for this module. Then the next step is to actually go through the installation steps. So the virtual machine will start up, we'll choose install and so on. There are a couple of important points here. The first one is the software selection. So it will actually ask you what kind of Linux installation you want to have. Do you want to have like a command line interface only? Do you want to have a server? Do you want to have a GNOME workstation? So you need to be careful with this, and you need to choose development and creative workstation. Once you do that, you also need to include these libraries inside it as well. If you don't, the installation will not be correct. You might be missing something that I want to use later on in the lab sheets, and we'll have to install it as an additional package. It will do updates, because the additional packages it will install will not be the same version as on the DVD, and things will get a bit more complicated, and we don't really want that. All right, so be very careful on these steps. Make sure that you follow them one by one. If you get stuck on something, if you're expecting an option somewhere and you don't see it, call us. All right, and we'll figure out which step you've missed and why you cannot find that particular option. So the installation of the operating system itself, it's important that we have these packages here because of what we actually want to use this for. So we are building a sort of virtualization server that you will install VMware inside it later on, and build virtual machines and network them and do some routing and do a bit of DNS and so on. So for routing a DNS to work and for the virtualization options to work, a few of these components need to actually be in place. So we need to make sure that these packages are there. Once that's done, then the next important step is the partitioning. So standard partitions in a Linux installation include a /boot directory, /boot partition that includes the main kernel of the operating system, so the main program that runs everything. You have a swap space that acts as additional RAM for the system in case you run out. You won't in ours, but it's fine. You have a / directory that includes all of the subdirectories underneath it, and you have a / home directory as well that includes all of the user accounts for all of your users. And this is the one that we need to get rid of. So your hard drive is 200 gigabytes of space. Once you accept a standard partitioning, it will give about 150 of those gigabytes into the /home directory, because theoretically in any Linux system you will have your users and their home directories will be in /home, so they need to have the most space available there. However, we will always be logging in and working as user root, because everything that we will do will require you to log in as user root. So we need to be able to have all of the hard drive space available for user root to use. To do that, you'll need to actually delete the /home partition and then go on to the / and make sure that you get all of the rest of the hard drive space allocated onto that partition. So you should end up with 190 something gigabytes of space for the / partition in your hard drive partitioning. If you're unsure about this, give us a call again in the lab. This is a very important bit, because later on, once you build all the 4 virtual machines and everything that goes with them, you will run out of space, and there is no remedy to this. You'll have to rebuild your host Prometheus from scratch. Okay, so be very careful, make sure that you're confident, that you're happy with the customized partitioning on your system. Once that's done, we deal with the network side of things. So all of the computers in the lab are on subnet 28. First of all, the university owns the Class B network of 148.197.0.0. Yay for us. All right. It's kind of a big deal if you're a nerd, I guess. I don't know. So when the IP addressing scheme first came out, one of our technicians, Phil, said, oh, that's a good idea. Let me get a Class B, 65,000 IP addresses for us to be able to use. So yes, that's why we have it. All right. So in that Class B, we own, the lab owns, uses subnet 28, which is a Class C network that allows for 254 addresses in there as well. So we have 48 computers in the lab, and those 48 computers are addressed from 1 to 48. So depending on which computer you're sitting on, if you look at your monitor on the bottom left corner, you'll have a blue sticker that has a number that goes from 1 to 48. This is the IP address of the computer that you're working on. We are bridging the virtual machine, so this means that Prometheus will be located on the same subnet as our host, same subnet as our bridge. So we need to have another address on subnet 28 to use for our Prometheus virtual machine. The convention that we use in the lab about this is whatever IP address is on the little sticker on your monitor plus 50. All right, so if you're working on computer 28.10, your Prometheus must be 28.60. Be very careful about this. Don't use the same IP address as the host. You cannot have the same IP addresses on 2 computers. Yeah, it's going to be an IP address conflict. Annoyingly, it will work, but half of the time. So you will have very intermittent internet, and also your virtual machine or your host, even worse, will crawl to a halt while it's trying to figure out where the information is supposed to go. All right. So remember that Prometheus must be plus 50 of whatever you have on your monitor. Subnet mask is the default Class C subnet mask, and gateway for our lab is 28.254 and DNS is 28.251. The search domain, which is netlab ePortes UK, belongs to the lab. Your computers will also have a name. They are Formula 1 drivers. All right. So your virtual machine that you're building will be called Prometheus.netlab ePortes UK. All right. They all mean something, and you'll figure out exactly what in the last lab sit because you have to change them. Okay, but it needs to be there as well. So you need to make sure that the host name is set to Prometheus netlab ePortes UK at the installation step. If you don't, you'll then have to go into the operating system, into the etc. hostname file, change it there, and restart the virtual machine. So it's not the end of the world if you miss it, but while you're there, you might as well do it from the beginning and get it right first time. Start the installation and everything else. It will do its thing. It will finish the installation. It will ask you for a user account because Linux will ask you for a user account, and even though you'll never use it, create one, give it a password of whatever you like, and then go in to the main operating system. So once you're logged in, you need to log in as user root, and I would like you to always log in as user root, please, because otherwise you will have to switch user all the time. So theoretically, in principle, in Linux, if you're working on a system, always it's best practice to log in as a normal user, and anytime you have an administrative task, you SU, so you switch to your root user and elevate your privileges and do whatever it is that you need to do. All right, so when you finish university and you go out to the real world, do that. However, because here you're in an isolated environment, both network-wise and everything else, and everything that you will do here will be an administrative task, it will be just a terrible waste of time to just SU all the time to do everything. Okay, so please log in as root, make your life and my life easier if I come to help you afterwards. All right. Now, once you've installed the operating system and you're logged in, we need to make sure that you can find your way around the operating system as much as possible. Okay, so give me a show of hands if you've used Linux before. All right, very promising. So if you haven't ever used Linux before, here is a bunch of commands for you to try out and learn. Okay, so basically you need to learn at least the most basic commands of how you navigate your way around the file system, how you get to do some most basic tasks on it, so that this makes your life easier later on. All of these commands, I need you to document them on the logbook, okay, and say, the ls command lists the contents of the current working directory. Done. If you are struggling with a command, the most useful command of all commands is the man command. Man, not as in man versus woman, man as in manual. All right. So man ls will give you the manual page for the ls command. It will tell you what it does. It will tell you how to use it, what options it takes, and everything else that comes with it. Okay. So go through these commands, figure your way out through them, and then there's some networking commands as well that I definitely want you to explore. So because you can start and stop your networking or configure or deconfigure your networking completely from a terminal, and you can basically do everything from a terminal. So I want you to play around with this and figure out how they work. This will break your internet, but a simple restart will just fix everything, or a service network restart will fix everything. Okay, so play around. The purpose of this is for you to figure out how everything works. Okay. Then I want you to connect onto our file server in the lab. So it's called netserve. We connect to it through SSH. So I would like you to connect to it and see what sort of information, you can download from there, the information that you can find on it, and so on. And then finally, I want you to download Google Chrome onto your Prometheus, and I want you to also figure out how to make it run as user root. Okay, because as we said, in Linux you should always log in as a normal user and only elevate your privileges if you need to do something. That's why Google Chrome doesn't actually run when you're physically actually logged in as user root. All right, there's a workaround it. You need to figure out what it is and do it. I am recommending that we use Google Chrome for the simple purpose that you will need to keep a logbook on everything that you're doing, and the logbook needs to be a Google Doc. All right, so this will be the easiest way for you to use the Google Doc, as the Chrome is more compatible than Firefox or Opera actually are with it. So once that's done, this is lab sheet 1. Depending on your previous experience with Linux or not, this will take 1 or 2 weeks to do. Okay. We have, I think, if I remember correctly, 6 or 7 sessions in total in the lab. So it's not the end of the world if you run out of time and you don't manage to complete all of the tasks in the first session. Okay, it's fine if you have to take the second session as well. However, the progress in general of the module is supposed to go at your own pace. All right, so some of you might go through all of this within the first week and might want to move on further on as well. So that's why I will explain the second lab sheet as well, which is a virtual network setup. All right, or as much of it as I can in the next half hour. Okay, so by the end of the first lab sheet, you have built your Prometheus virtual machine and you can work onto it. Everything that you do in the module needs to happen inside that virtual machine. Okay, nothing should actually happen on the host itself. On the host itself, you should only log in when you come into class, start up VMware Player, and start up your Prometheus VM. Once you're there, you can basically full screen it, open Google Chrome, get your logbook, and then go to Moodle, get the lab sheets and all the material that you need, and work on the lab sheet and make sure that you take screenshots and so on. So what we want to use is we want to create a virtual network. So we want to create a network of virtual machines inside our Prometheus VM. And this is where that Intel VT option comes in handy for the virtualization extensions for Prometheus. So when you do this lab sheet, you will get stuck at some point because the virtual machines won't start unless you've actually enabled that option for the CPU, for the processor. All right. So once you have that enabled, you'll be able to basically go on with everything on this. So you need to install VMware Player onto this. So the link to go and get it is here. Make sure that you download version 17. It is version 17. Make sure you get the Linux version of it and not the Windows version of it because they're not the same. Okay. you will download the file that's called VMware Player something full 17, and then the version numbers, the full version numbers. It should end in .bundle. If it doesn't end in .bundle, you have the wrong thing. Okay. This should run with / VMware Player and so on and so on. You might need, because you're logged in as user root, you might need to change the permissions on the file after you download it, and to change permissions you use the chmod command to do that. All right. If you actually type ls in a terminal to see it, you'll see that it will turn from black or red into green, and if it's green it means it's executable and you're good to go. So once you've installed VMware Player, the installation steps for the software itself are pretty simple and self-explanatory. Just accept all defaults, you don't need to do anything, don't participate in any programs and don't get any notifications, don't give your email to anything that it asks, and so on. Just move through the installation steps with as little hassle as possible, and then you're ready to basically build a VM inside your VM. So the virtual machine that we will create will be not be as strong as the one you've created for Prometheus. All right, it will be a VM that will have a space of 10 gigabytes. It will have about 2 gigabytes of RAM, and you will need to do that by customizing hardware in the end. However, this particular installation can be an unattended installation. All right, so you don't have to choose the software and everything else for it. So you just create a software installation for a GNOME desktop, which is the default. So it will basically, once you've built the virtual machine itself and you start the installation, it will only ask you for the root password and nothing else. So it will build itself. It will take, I think, about 5 or 10 minutes, and then it will just be able to run. So to run it, you just play, you log into the virtual machine. By default, it will be configured for NAT. So NAT means Network Address Translation. So it's basically what all of your routers do for internet at home. Okay, so you have a public address on the outside of it, and then the NAT will give you a private IP address for your network to use on the inside. So this is what it will be. It will be automatic, so it will get its own IP address and everything else, and it will be able to just have internet access straight away onto your computer. So this is in contrast to your bridged Prometheus that you've configured an address on 28 dot whatever on the previous step, on the previous lab sheet. So now once that's installed, again it will ask for a username and password. Again, I would like you to always log in as user root with a password of localhost 1, and so on. So you have one virtual machine that it's built in an unattended way, and it's on a NAT network card. What we want to do is we want to build a network of this, and we want to connect all of them together eventually. So we need to have 2 more virtual machines. So I have a network diagram. All right, so your host is the Prometheus VM, which is on the bottom left, and then the 3 other virtual machines that you will need to have will be VP0, VP1, and VP2. All right, so these 3 virtual machines, you will build them inside your Prometheus virtual machine, and they will need to be networked in this specific way. So just like we use subnet 28 for the lab's physical IP addresses, we also own subnets 30, 31, and 32 that are for us to play around and use in the lab itself. All right, so the first branch of the network that connects Prometheus onto 0 is on VMnet 0, on network 0, and it's on subnet 30. So all of the addresses in there will start with 148.197.30 something. The second branch from VMnet 1 onto virtual machine 1 is on 31, and then the third branch is on subnet 32, and that connects virtual machine 1 to virtual machine 2 in the end. So in order to build this network diagram, we need to do a few things. First of all, we need to have those 3 virtual machines built. We built one of them. The easiest thing that we can do is clone it 2 more times so that we create the other 2 virtual machines. So this process is described here on this paragraph here. All right, so you take the virtual machine that you've built, the VP0, you essentially copy and paste the files from that virtual machine onto the folder next to it, rename them, start them up, and then rename the virtual machines themselves from the operating system inside by editing the etc. hostname file. So now you have 3 virtual machines that are NATed. They have whatever IP addresses are given to them by the system, okay, and they have the correct names that you want them to have. Once that's done, you then need to sort out the network. So to sort out the network, we need to first of all have the option to use the network cards that we want to use. So the network cards for VMware are called VMnet something. By default, VMware uses 3 different networking modes. One of them is NAT, which is the virtual machine that you have here. One of them is Bridge, which is your Prometheus, and the other one is host only. Host only allows you to give whatever network information you want onto the virtual machine that you've built. All right, and it creates an environment which is isolated from the rest of the world. All right, so if it's a host-only virtual machine, or if it's a group of host-only virtual machines on the same network, they will only be able to contact each other, but not the outside world. We don't want to do this, so we want to customize the networking capabilities of the software itself. So we have a script that changes that, and the little script that we use is called fix vmnet dev, as in it was broken before. So what that script does, and you don't need to worry about the script at all, you can open it and read it and see what's in there and what it does. All it does is it goes into the configuration file for each of the virtual machines that you run to, takes the information for the network card, whether you set it to NAT, Bridge, or whatever, and replaces it with its own custom section. So that creates 3 custom network cards on the virtual machine that you had. So from one NATed network card, you will go to 3 custom network cards in the settings. Those custom network cards need to connect to the correct virtual network cards in order to communicate with each other. So looking at the diagram here, we need to have virtual machine 0 connecting to VMnet 0. We need to have virtual machine 1 connecting to VMnets 1 and 2, and virtual machine 2 connecting to VMnet 2. And then, of course, we need to have the host, your Prometheus VM, with VMnet 0 and 1. To give the correct network cards to these virtual machines, all you need to do is select them from a drop-down menu in the settings of the virtual machines, and it's done. However, to get these network cards to run on Prometheus, whose file we have not altered because we haven't run the fix vmnet script there, we need to have another script that runs and creates those network cards for us. This script is called vm_subnet. These are all available on Moodle, by the way, and they are on NetZero as well, so you will download them and use them. All right. So this script will configure and run VMnet 0 and VMnet 1 on Prometheus. So you run the script on Prometheus itself, and it will configure and start VMnet 0 and VMnet 1, so that then these virtual machines can connect onto them. It will also start as processes. It will also start as a process, VMnet 2, but it will not configure it with IP addresses and so on. All right, so now we have our network cards, we have our virtual machines. We need to give them all correct IP addresses. So we're in lab with 48 computers, 48 students. We want to give public IP addresses to 48 times 3 virtual machines, plus the 2 network cards that are on Prometheus as well. So we need to have a way to figure out so that you don't all give the computers, give your network cards an IP address of 192.168.0.1 or 148.197.30.1 and so on. So in order to achieve this, we have another file. Let me find it. Go to Drive. It's the subnet file. This lovely thing. So we have 48 computers in the lab, and we need to make sure that everybody sitting on them can allocate 6 different IP addresses on the virtual machines inside them without having any IP address conflicts. So the way to do this is we've taken a class C network whether it will be 148.197.30.0 or 31.0 or 32.0, and we split it into as many slices as we need in order to accommodate all of the computers in the lab. So in the lab we have 48 computers, starting from 1 and going all the way up to 48. All right. So in order to split the network that is the default class C network that starts from 30.0 and goes all the way down to 30.255, we need to find a way and see what happens if we divide this enough times to fit the 48 computers that we have. Now, because everything that we do with the IP address is in binary, whatever split we do needs to be a power of 2. All right. So if we take the one class C network and split it into 2, 48 computers don't fit, then our next option is 4, 8, 16, 32, 64 slices. Yeah? So 64 network slices will fit our 48 computers and will give us a few spares to have to play around with as well. So 64 is the number that we need. All right. So we need to have 64 networks out of the one class C network. In order to do this, we need to basically split this into 64 slices and see what's left afterwards. Now, to get 64 different networks, we need to have 6 digits in binary in order to do this, because it's 2 to the 6 or whatever it is. And this for the computer itself means that we'll have to change the subnet mask on the network. So a computer doesn't see decimals, it sees binaries. Okay, so a default class C subnet mask is 255.255.255.0. What we're doing, because we're subnetting, we're breaking this network into 64 slices, we need to change the subnet mask so that we change the dimension, the length of the network itself. And because we need 64 slices, we need enough combinations of digits to accommodate for 64 different combinations. So we've taken away the digits from here. So on a class C subnet mask, this would look as 8 ones, 8 ones, 8 ones, 8 zeros. Does anybody know why? What's the relation between this 255 and these 8 ones here? Yes?
They're the same number except one's in binary and one's binary?
Yes, they are the same number. All right, so this is a simple binary to decimal conversion. Okay, so this is 8 bits. So you start with 1, 2, 4, 8, 16, 32, 64, 128. If you add all these up, 128 plus 64 plus 32 plus 16 and so on, it works out at 255. Okay, so because we here have stolen 6 of these 8 bits, then these 6 bits will give us our new subnet mask. And if you add these up, 128 plus 64 and so on, they will give us 252. So the new subnet mask for our network will be 252. This also means that we only have 2 digits left available for addresses for our networks. And 2 digits give us what? 00, 01, 10, 11. Gives us 4 different combinations. Those 4 different combinations are reflected into the number of addresses available for our little network for each of the computers here. So for Farina, we have one address of 30.0, one address of 30.1, one address of 30.2, and one address of 30.3. So Farina gets 4 numbers. However, because this is networking, and we need to know the beginning and the end of the network, we always need to allocate a network and a broadcast address. So the network address will be the first address in the range, and the broadcast address will be the last address of the range. So for Farina, we're wasting those 2 addresses, boo-hoo, and we only end up with 2 usable IP addresses of 1 and 2. If we go back into our little network diagram, this means that for Farina, I can have 30.1 and 30.2 here. So I only need 2 IP addresses anyway, because I only have 2 network cards that I need to give IP addresses to in each of the branches of my network diagram. So I can have 30.1, 30.2 here. On the other ones, they are on the same range of networks, however, they are on a different subnet. This is on subnet 31 now, so I can still do 31.1 and 31.2, and of course I can do 32.1, 32.2. So I have two addresses available in my range of addresses, however, I have the ability to use 3 different subnets. So that gives me 6 usable IP addresses for my little virtual network, and surprise, surprise, that's all I need. Okay, so this script here, when it says vmnet IP, if I was sitting on Farina, I would use 30.1 as the IP address, I would use 252 as the subnet mask, and this will be the same for all of you, of course. And then my network address will be 30.0, and my broadcast address will be 30.3, taken directly from the subnets file as you look at it. All right, so yes, they all come together in the end in this script, and it's a bit tricky, but this is the way to do it in order to subnet it and make sure that you all have different IP addresses for the virtual machines that you're using. Okay, I will explain this more in the lab, so don't worry about it. Plus this gets recorded, so you can play this back whenever you like. All right, it will be on Moodle by tonight. So this is the explanation of how we end up with all of the IP addresses in our little network, and this is how we end up with this in the end, without worrying about using duplicate IP addresses and so on. So by the end of this second lab sheet, you should have your Prometheus built from the previous lab sheet, your 3 virtual machines inside Prometheus, 0, 1, and 2. They should have network cards because you run all of the correct scripts, and the network cards should have the correct IP addresses according to the network diagram that corresponds to your own computer. If you go on Moodle, you will see that there is a virtual network diagram template. So I have it in a docx format, you can actually download it, and I do want you all to have the network diagram in your logbooks that corresponds to the correct IP addresses for the computer that you're working on, because that will be your roadmap for the rest of the teaching block. That's what you will use in order to know which IP addresses to use everywhere and with default gateways and everything else. Okay, I actually went through this on time. Very happy about this. Okay, you probably have lots of questions, right? I will explain this again in the class as well, though, when we get there. All right. So, do you have any questions not specific to CIDR, to the addresses? So, yes.
It was the name of the book you recommended for Linux, Red Hat?
Yes, Red Hat Unleashed, yes.
So, would reading that help me understand?
Not so much. Yes, good point. Thank you. So, in order to understand subnetting better, if you go on Moodle, you will find that I have this link. So this link will take you to a website called firewall.cx. Please, we're not finished yet and I'm still recording this. So, if you go onto this website, and if you go into networking, you can find everything that you need for CIDR and everything else. So if you do want to read a little bit more about CIDR, this is all explained here as well, with nice, colorful diagrams and so on and so forth. Okay? Good. All right. Anything else? Yes?
Could you remind me what CDR stands for?
CIDR, Classless Inter-Domain Routing. Because it was a class C network that we're using, but we're breaking it into smaller, so we're going beyond classes, so it's called classless.
So you would say it's better for research than that book?
That book is only for the operating system, only for Red Hat.
Which part of that would happen? And we are also doing something with the operating system when we do the lab, right?
Yes.
So it's also good to read that book?
Yes, of course. Anything else? Okay, thank you very much.